In this video, we're going to look at Newton's first law, the law of inertia. We're going to firstly revise force and what balanced forces are. We're then going to look briefly at who Isaac Newton was, and then look at Newton's first law, the law of inertia. We'll then define inertia and talk briefly about friction. As you'll remember from previous years, force is a push, pull, or twist that causes an object to change shape, change speed, change direction, or stop. Okay, so it's a force does something. Force is measured in the unit newtons, and they're named after Sir Isaac Newton, and we'll talk about him shortly. When forces are equal and in opposite directions, they are said to be balanced. So here we've got three men all pulling with equal force in opposite directions. So we have a balanced force. In this case, we say that there's no net force, in that the force in one direction cancels out the force in the other direction, so there is no net force. Isaac Newton was an English scientist. He studied physics, mathematics, astronomy, a whole swathe of different things, and is probably one of the biggest contributors to our understanding of science that we have at the moment. In fact, he invented calculus, which you learn in mathematics, as a way to describe motion in the terms we think of it today, because nobody had done this before. They had no way to describe the motion and measure motion, so he invented a whole branch of mathematics just so that you could do this. Okay, it's Newton's first law, also called the law of inertia, is in two parts. The first part is an object at rest will stay at rest unless it's acted on by an unbalanced force, which makes sense. If something's sitting there, it's going to stay sitting there unless something happens to it. The second half is that an object in motion will stay in motion unless acted on by an unbalanced force. So this means that if something's moving, it's going to continue moving unless something stops it from moving, which again makes sense. Inertia is a property that all objects have, or any object that has mass has, and it's its ability to resist a change in motion. So for example, if it's stopped, to stay stopped, or if it's moving, to keep moving. And objects with a larger mass have more inertia. So bigger things and heavier things have more inertia. So it takes more for them to get moving or to stop. Now when we're talking about Newton's first law, and especially when we're thinking about the second half of it, objects in motion will stay in motion unless acted on by an unbalanced force. Something that we need to keep in mind is friction. Now, friction is a force that occurs at the contact of two surfaces, and one of these surfaces may be air friction we call drag. And this is a force that opposes motion or causes things to slow down. So if something's moving, it may appear that no forces are acting on it. However, friction is usually acting on an object, and that will cause it to slow down and stop. So with the unless acted on by an unbalanced force, you've got to remember that friction occurs. In this video, we've revised force as something that causes an object to do something with motion. We've looked at balanced forces, being forces of an equal magnitude or size in an opposite direction that cancel each other out so that there is no net force or no total force. We've talked about Isaac Newton, the English scientist who invented calculus as well as came up with the laws that we use to describe motion to this day. We've looked at Newton's first law, the law of inertia, which states that an object at rest will stay at rest unless acted on by an unbalanced force, and an object in motion will stay in motion unless acted on by an unbalanced force. We've talked about inertia as the property of an object to resist a change in motion, so whether to resist stopping or slowing down or speeding up, depending on what motion it's in. And we've looked at friction being a force that you can't really see, that is pretty much always happening, so you need to take that into account when studying motion.